जावेद YouTube पे लाइव कर दिया है? Okay. So, good morning, everyone. My name is Virendra. Welcome to Aries and welcome to the last day of our week-long National Science Day celebrations. Many of you have seen and joined us in our other activities on other days. First day we had the inauguration, and then we had a talk on sun. Then on the second day, the theme was atmospheric science. We also had a live weather balloon launch. Some of the students who came in person that day also participated, and as well as some of the students who joined in the online mode. Then followed by that, for 24th and 25th, we had a Skywatch program to see stars and nebulae, things like that, and sunspots in Gurukul Kangri University, Haridwar. And then today is our concluding program, and that's how we have quite a number of activities planned for today. So before we officially start with the activities and the talks for today, I would request our director, Professor Banerjee, to honor the memory of Sir C.V. Raman by lighting the lamp. Now I invite my senior colleague, Dr. Shashi Bhushan Pandey. Kumarji, our next speaker for today, please. We have the principal of Jawahar Navodaya Vidyalaya with us. Sir, I also request you to join us. Thanks. Thank you, everyone. So with this, we'll be formally starting today's activities. And I especially thank our director, Professor Dipankar Banerjee, that he joined us. On the first day, he has already given his talk on sun. So today, he'll not be speaking on any particular subject. But before we proceed with the program, I would specially request him just to mention a couple of words to the young audience over here.
Good morning.
Good morning, sir.
So this sounds much better, because in the Zoom you don't hear this. So finally, I think I'm really happy to see youngsters, young minds, face to face. And we are really, really starving for last 2 years that we have not been able to do that. I have joined this institute as a director about 2 years back. It was severe winter, so our activities were slightly less, and then COVID took away everything from us in terms of our social interaction, because this is very important. Whatever we do here, we have our own passion. We feel excited about it, and we are fortunate to be able to pursue our own hobbies, actually. I mean, I often said that government pays me for my hobby. Apart from my studies, we travel across the globe. I personally go for chasing eclipses. I've been to China, I've been to Easter Island. Not many people even know where exactly Easter Island is. I've been to with the military aircraft, AN-32, Indian military people in the space to observe solar eclipse. So the point is really we feel excited about what we do. And unless we are able to share our excitement and bit of knowledge with you, our job is, half done. Absolutely. So I'm really happy that, again, we are getting into probably some sense of normalcy. And National Science Day, no other better day to, start doing that in more full swing. So I'm happy with, my colleagues have been able to put up some program, the combination of in person and, online. This is probably going to be the future hybrid modes of scientific and, training program, whether it is, but definitely we'd like to have very regular, activities here where there will be possibilities of in-person participation. It could be night sky observing, day sky observing, or certain competitions. See, sometimes, today you'll be having few competitions, I understand. Competitions allows you to participate a little more actively. I mean, more people can join. It just sort of giving you a little bit of, additional kick. But I would say that you are in our neighborhood, and fortunately we are here. So please, contact my colleagues here. Try to see from the school whenever you want to have such activities. We'll have a regular calendar of events, and we'll try to accommodate, particularly those who are interested. If you have astronomy club in your school, then also sometimes, enthusiastic students are part of that club, so that club can visit here and continue with, certain other learning exercises. You see, we do astrophysics here and atmospheric science. Both the subject areas are very closely linked with physics, because in the schools you only study physics. We don't expect also to know, how the black holes are formed and things like that. So there are certain interest in individual, students may have, and that, inquisitiveness you can, get clarified by interacting with my colleagues here. So again, I'm very happy to see all of you here. So all the best for today's activities. I hope you enjoy it, and give us your feedback also time to time, the way we can improve our activities as well. Because unless we know that whatever we have tried to transpire to you, you have been able to absorb it, our job is again half done. So please give us the feedback also that you would like to have this kind of program or this kind of activity in the days ahead. So again, all the best, and thank you for coming. Thank you.
Thank you, sir. Thank you for welcoming the students and giving us your views on how this time has been and how the future might be. In fact, this is particularly relevant because the theme of this year's National Science Day is also integrated approach to science and technology. Okay. So with this, we'll be formally starting with today's program. Over here, we have mainly 4 different areas, you can say. Out of that, on the first day, we had the talk by our director, Professor Banerjee, on sun. On the second day, it was atmosphere. So our atmospheric scientist, Dr. Narendra Singh, he gave talk on atmosphere, and we had the weather balloon launch. We also had the slogan writing competition for class 6 to 8 students. And so today we have 2 themes. The first is astronomy, and then the second is engineering, because a lot of these instruments also require a very complicated engineering aspects, which requires a dedicated team. So with this, I invite my senior colleague, Dr. Shashi Bhushan Pandey, to give a talk about astronomy. Professor, sorry, Dr. Pandey, he is an astronomer who uses these big telescopes to observe night sky phenomena, particularly transient phenomena, things which happen over the very short period of time, but which are one of the most energetic kind of processes in the universe. Okay, so some of these terms probably you might have heard in newspapers or science articles, things like supernova, gamma ray burst. Okay, so he works with things like that, and he also did his PhD at Aries itself. So with this, I request my colleague.
Thanks, Virendra, and I welcome you on behalf of Aries again on this occasion. That's National Science Day, 28th of February. I don't think I need to introduce this subject. You all are aware about it. And as Virendra mentioned, my subject area and all, I would rather like to touch upon a very different perspective today, which is based on not really my own core research area, but please go back. Yeah. So, yeah.
I'll share the screen first.
Okay. So once we talk about, science and technology, it means both terms are sort of correlated, right? Because earlier, in olden days, if you might have heard about our old mathematicians and saints and Maharshis and all, they kind of observed the universe through naked eyes, or through bamboo tubes. And they kind of measured that whatever. Now today we know that whatever they told us about the universe, particularly about our planetary systems and so on, they are broadly, I won't claim that it is as correct as few decimal places, but we can't really challenge that, right? But as technology evolved, we started using telescopes, and we increased the diameter of the telescope. And some of you are intermediate high school students, so the diameter of telescope is important because it probes fainter, and that's how you see farther, right? That's a very simple thing, because I'm talking astronomy, so that's how throughout I'm using astronomical terms. So this year's theme is integrated approach in science and technology for sustainable future. That's what the theme of this year is. And is over? Okay.
This one.
All right. So integrated approach in science and technology for sustainable future. That's what is the theme for this year from Department of Science and Technology, one of the departments of central government, the funding agency for this institute, Aries, whereas our director, Professor Dipankar Banerjee, mentioned that we do activities towards astronomy and atmospheric sciences. So integrated means the combined approach in science and technology, let's say astronomy, for sustainable future. So what sustainable means? That's the very kind of catchy word which this year's theme is. And if you go to Oxford Dictionary and try to search what sustainable means, then you will find that it's basically an adjective, and sustainability is another, which is represented as noun. And the meaning of these two words,
it's closer to me, so I'll find this.
All right. I can do it. Yeah. So sustainable word that can continue or to be continued for a long time, or involving to use natural products and energy in a way that does not harm the environment. So while doing astronomy, if we try to understand that how we are going to fulfill these two, definitions or meaning of this word sustainability, because it is used by our government and internationally also it is proposed. So this sustainability, that involving to use natural products and energy in a way that does not harm the environment. It means if we are using a telescope And I'm saying that telescope, we are increasing the diameter and increasing diameter to get fainter and deeper. Then what does it mean? While doing that, we should also think that are we harming any kind of environmental aspect or environment harm, or we are causing, some damage to our environment in which actually we are living. So that's a very important point, right? So in our deeds and in our activities, we must ensure that we are not doing anything which is permanent, creating any kind of permanent harm or damage to our environment, to our planet, because there is no planet B, right? We have only one planet to live. So whatever we do, whether we do technology, science, arts, whatever, we must ensure that the environment is protected. It is not damaged, because unless we have a clean air to breathe, unless we have a clean place to live, unless we have, environment is clean, like for example, the greenhouse effect and, producing more carbon and more carbon dioxide. That's a very much global problem, and everybody is concerned about it. And in Paris, there was a meeting in 2015 to all globally, all science and technologists and scientists gathered together to discuss that whatever research we do, how can we make global warming as down as possible to make sure that the projected enhancement of the overall temperature of the earth is minimized to a level which is acceptable to make the environment, a very, very, let us say, sustainable. Okay. So the close by words, defensible, tenable, maintainable, strong, supportable, reliable, credible, visible, plausible. I mean, these are not synonyms, but I'm saying these close by words which to emphasize that what the word sustainable means. So if we catch up on only one aspect, that is the meaning here, that does not harm the environment. So through astronomy, how we can do that? And how we are doing that, apart from doing science, proposing that, like our honorable director said, that to know that, the black hole, how black hole forms, that's fine. But when we say how black hole is formed, it means to understand that we are using a lot of our brain, where we can assume that definitely not much carbon is coming out. But if we are using a computer network, and to build all those computers and RAM and memory and hard disk and hardware, all, we must have gone through, some industrial process where carbon is emitted. And that carbon has ultimately contributed some way to harm the environment, and to up to a certain extent to say that it has added towards global warming. If we are for some collaborative purpose, if we are flying to US and the long haul flight going from here to US is definitely, if there are 400 people sitting in the flight, like the big one, and if you see that the fuel was consumed in that long haul flight, and if you normalize and divide it by 400, then you will see that per person, if you are traveling for a few times in a year, then you have contributed a few tons of carbon into atmosphere. So does it mean that we should not travel? Then how the collaboration and how these kind of activities, what I'm talking about, will flourish and how it will evolve? So these are two, very contradictory things. So my point, again, the first sentence which I passed, that while doing our deeds, we should ensure, or we have to ensure, to maintain and to protect our environment, that whatever we do, probably we should also, in some corner of our mind, we should ensure and think that how our environment is protected. And if Our environment could be protected in many ways. One example which I took is the carbon emission. If I'm writing an email to some of my friends or colleagues, it means while writing an email, I use the network, I use the computer, I use the power in generating that power. Definitely some kind of coal burning or nuclear reactor or some kind of process has happened because of which the electrical supply came to me, and that's how I use the computer, and that's how I was able to write that email. And those hardwares which were there in building that computer and network had also passed through some industrial process. So each and every step you are adding some carbon to the environment. So how to make a balance between the two? Because we can't stop our development. We can't stop our, growth towards science and technology, because that is equally important. Otherwise, human beings will not be able to survive at all. So to make sure that our survival is there, we have to, pass through a developmental phase. And to develop that, whatever process we do, whether we do astronomy or medical sciences, we have to make sure that some sort of sustainability is achieved. So that's what is the theme of my today's talk. Next, please. Yeah, and since I'm talking about astronomy, and most of you are students here, you should also know that what kind of aspects are related to astronomy. Once we talk about astronomy, it means we are talking about optics. As I said, it's telescope. And once you talk about optics, then it means you're talking about the light precision, adaptive optics kind of advanced techniques. Big data, machine learning, electronics, lot of signal processing is involved. Space, satellites are involved. Because most of the astronomy is done through space-based astronomy. Then physics is involved. Because whatever you observe, ultimately you are trying to interpret them in terms of physics. Then chemistry is involved, astrochemistry. What kind of elemental abundances are there? What kind of processes are going on which are Mendeleev stable? All 104 elements. Now we are probably have started understanding that all elements actually came from, after Big Bang, some process happened, and some hydrogen came, and then helium came, and then further big nuclei. So that's chemistry. Then biology, astrobiology. Do we have somewhere, life? Education. A lot of aspects of education are related with astronomy. Inspiration. People are getting inspired because of whatever we are doing. Philosophy is also connected to astronomy. Anthropology. So it's basically technology and skill, science and research, culture and society. So in these broad perspectives, we have, things are evolving. That's the International Astronomical Union, a figure taken from there. That's how they understand that astronomy has these many aspects. All right. There is an institution in NASA called Johnson Space Center at NASA. It's a dedicated institution to optimize resources through 6 broad categories. Whatever NASA mission is there, there's NASA sustainability policy to execute NASA missions without compromising the planet's resources, so that the future generation can meet their needs. So that sustainability also involves taking action in these 6 directions. That's energy, use of energy, optimization, renewable energy. That's the land, that's the real property, wildlife, vegetation, all those things, water, drinking water, the quality of water, how to manage the wastewater, air emissions, carbon and greenhouse gases, air quality, material, buying green, reusing waste disposables. And then it's all surrounded by people, sustainability, awareness, behavior, change, technology transfer, aspects like this. So if we think about, doing some sort of research or some sort of activity, whatever activity we do, no matter if I'm teaching in St. Joseph College, then due to my deeds and behavior, am I able to, think about a sustainable way to teach and to make sure that there is no harm to the environment where I'm living in? should be the prime goal. Next, please. All right. Since a lot of students are here, I would like to ensure here that you know that what kind of projects are there in India, which we are going to have, or what we have. As a general knowledge, you should all know about it. And here, you know, the x-axis is the year, 2020, 25, 30, 35, up to 40. And then y-axis is the electromagnetic wavelength. I think you all are aware about it, right? That's the gamma ray, X-ray, UV, optical, infrared, radio. So if you plot from gamma rays to radio, you will see that up to here, where you are sitting 2021, 22, we have many, many projects going on. This is the Indian Astronomical Observatory at various frequencies. So you should and you must know that India is doing well towards, you know, we have an X-ray payload in space that might have taken a lot of resources and a lot of efforts. And so have we counted that what kind of carbon emission was there? And did we really, it was all environment friendly, no carbon emission and stuffs like that were involved, and that's how we progressed up to here? If not, then in future, as you can see, that a lot of other missions are there, and here we are talking about many, many mega projects, like the 30-meter telescope, square kilometer array, LIGO India, which will go up to 35 and 40 kind of scales. And that's the era, because we'll be getting older and older, and we'll be out of the race at some stage. But it's all you people who will be working, you know, in 25 to 35 kind of area, and you'll be searching for jobs and so on. So in astronomy, if these kind of projects are there, and if these kind of, that's how we are progressing in our country, then should we really think about being sustainable for our environment, and to make sure that whatever deeds or whatever work or whatever research or whatever, you know, professional approach we adopt in our life, it all must be sustainable, right? So if we adopt this kind of approach in our life, then definitely we are going to achieve the goal, because there is no planet B, right? So next, please. All right. So there is a National Astronomy meeting in 21 by Royal Astronomical Society in UK. They met recently, last year, and they did something called carbon audit. That Royal Astronomical Society is one of the, you know, astronomical society where a lot of people are involved. 4,000 members are there globally, including their staff members, scientists, and so on. So what they did is that they took help of a carbon audit by a consultancy agency, and they found that in 2019, which was of course a normal year, because there was no pandemic, and a lot of travel and everything was going on as per normal. So they thought that the society emitted total of 283 tons of carbon dioxide. How? This equates to 13.5 ton of carbon dioxide per staff member, compared with the net zero, which is 2 ton per head. That's the rough number, that if we are able to produce 2 ton carbon dioxide per year, that's not going to affect or harm the society, the environment in an adverse way. But per person produced 13.5 ton. The majority of emission, 55%, was arose by travel of staff members, which are supported by grants. From government, we are getting grants, and then we are flying to US, we are flying to Australia for some collaborative purpose. So we must think that, was it necessary? Can we somehow optimize it, or let us say minimize it? Because if we are flying, if I am going to Haldwani by car alone, Let us say 5% are sitting, it means that carbon emission, whatever my car produces, is divided by 5. But if I am going alone in my car, it means it was, I contributed with a lot of carbon dioxide into the atmosphere. Was it necessary? Was it possible for me to go by bus? And things like that. So if we come up to that level of thinking in the society, then we would be contributing more, constructively, positively. But again, there is the dilemma that is it always possible? Would I really prefer with my son if I'm going alone comfortably in my car with my AC on, and then my family will be more happy? But if I'm going in the public bus, a lot of other issues will be there. I mean, wherever in the globe. So that's how we need to think that, and then energy requirements of the society premises, 23% carbon was there. And then in publication, printing, distribution. If we are printing something, it means we are using a piece of paper. That piece of paper is where it came from. It came from a tree, right? And when this piece of paper is junk and now we are burning and then producing a lot of unnecessary carbon in the atmosphere. So there the sustainability word doesn't apply. So that was one small example. Since there is less time, there is a Nature Astronomy paper. Nature Astronomy is a magazine with Nature, you all know, right? And they kind of did a very recent study by Burster. You Google it, you will find that here on the x-axis that the top 1% of income earners, how much they are contributing as far as carbon emission is concerned in the society. And then the top 10%, in the middle and the bottom. So, whosoever has a lot of money, they are producing more carbon into the atmosphere. And that's how they are harming the environment a lot. So do they need to be more responsible than poor people? It's one question. Next, please. Here are some pie charts. So MPIA, it's a research institute, and then ESO. ESO means, European Southern Observatory. You should know that all European countries, you might have heard about European countries, NATO, Ukraine, US. So all those NATO members, largely, I would say, they have put their facilities mostly in Atacama Desert in Chile. And that's one environmentally friendly thing that they all agreed that let us put our facilities to a common place. And that's where we can use our resources, and it would be good because it's a good astronomical site. People can go there, and not every country has, but there are other aspects that not every country can put, because optical observations particularly, they are so, urbanized that they cannot host telescope. That was one part. But now everybody is traveling to Chile. But are they contributing more than what they thought that it would be better if we keep our facilities to a single place? And aspects like that. So as you can see that all those different institutions, and in Australia as well. So they said that electricity, flights, office heating, commuting, and others. So they divided these color-coded aspects, as you can see. And they found that, for example, ESO say that to maintain the energy, 41% of carbon is contributed, CO2 per year per researcher. That's the number. So, and then purchases, they then travel. Here you see the European participants and the ESA, one of the conference. Like, for example, going in one conference, how the carbon budget, because we are talking about the carbon audit. Because whatever activity we do, we are always producing some carbon. So our carbon footprint, and before doing any activity, we must think that, are we going to produce some carbon out of it? Then it is going to harm the environment in a certain way. And if that is the approach, then that's where our, our deeds and our activities and our thought process will be controlled. And that's how it will produce something called sustainability in the society, right? No matter whether you are going to St. Joseph College, can you go by bike or your father should drop you by your car? So that makes a difference. Can you walk from Talital to St. Joseph College? That will make a difference. Because zero carbon emission. And you got some exercises. And your job was also done. So aspects like that. So that's what the European participants and international participants. International participants, only 10% were there, but they contributed 50% of the carbon budget. With the long haul flights, they contribute enormous. Next, please. And as I said, there is no planet B. Next, please. All right, what internationally we are doing? That the full cycle project or any instrument must be considered with the emission budget. For example, giant array of neutrino detection at last, square kilometer array. In these proposals, these are the big proposals in astronomy. If you see, they are all talking about their carbon budgets, that how you are going to improve and how you are going to make sure that the less carbon is emitted and the environment is protected. That's how in future we are going to behave. In some area, path of zero emission, clear that electrical energy is no longer produced by burning fossil fuels. It should be all renewable, preferably local electricity generation and so on. Because that is producing a lot of carbon. It's not environment friendly. No sustainability. Several institutes and universities have started to invest their own solar power plants. Remote observatory, usually at sunniest places on the planet, can move to green energy. Green energy, you know, there are various types. I think in high school books, I have seen this definition, so I don't need to tell, right? It's the green energy. Next, please. So some suggestions to achieve this goal. How can we achieve this goal? One of the most challenging areas to decarbonize long distance flights, which contribute 20 to 25% of the total carbon emission per institute. There is simply no alternative to burning fossil fuels. This is too required and to sustain a frequent flyer attitude, particularly in case of intercontinental flights. So unless it is necessary, don't fly, because that is going to contribute enormous amount of carbon. For national and regional trips, trains are better. That's how internationally people are concerned. During COVID-19, we have shown that our discipline can adopt to a complete cessation of flight. We don't actually need to travel physically or effectively to communicate with each other. We don't need to travel physically. In fact, there is an increasing consensus that replacing real-time conferences by just virtual meetings. All your classes happen, you know, teachers taught you without going to your college. You did not go, but just by using some Zoom session and online systems, and you got your, you know, the whole year done. And I think more or less it was not that bad, my experience. I have also kids, so I have seen that it was not too bad. But anyway, something happened. But you know, a lot of carbon emission was suppressed. So we must avoid to call something like go back to normal. There is nothing like that. So it's all whatever we taught, whatever we learned from COVID pandemic is new, better, normal. And that's how it is sustainable. Next, please. ESO, again, I was talking about ESO as the big observatory, just 2 minutes more. The ESO, European Southern Observatory, they have taken new measures. You read it too. I'm not going to read. Let's read some of them to ensure that all the main aspects of our activity, including operations, information technology, resource management, are efficient, productive to the environment. Consider environmental stewardship and energy consumption to maintain the public commitment in meaningful and achievable green goals, to promote energy conservation and environmental things, to have a strategy that supports reducing cost, lowering complexity, increasing operating efficiency, and so on. So these kind of, that's how the big observatories, because I'm talking all in terms of astronomy. So ESO is one of the standard examples for us. because they do one of the best, research in the world. So that's how they are going in terms of going green. That how to make sure that, lesser and lesser amount of carbon is emitted by all the way from organizations to individuals. And that's how we are contributing to the society. Next, please. And this is my last slide, probably. Yes. What we are doing, apart from doing research like understanding sun and black hole and developing technology and running telescopes, and that's what our business is, right? What we have done, how we are ensuring that minimum carbon is emitted, and our contribution to optimizing or saving or protecting the environment has happened. There are very small examples, but you'll be amazed to know that they're important. We have minimized, optimized our air travels, partly due to travel, but now we think a lot our budget allocation, because when I'm traveling, I will definitely would like that TA expenses should not be met from my pocket, but from my institute. The institute will give, but definitely I have to make sure that whether really should I travel or can I do it by Zoom session or just by participating online. That's where most of the carbon is cut. Sustainability. Reducing printing, etc., going more towards online functioning mode. So if some approval is required, then I don't need to write a piece of paper and go to my director and you took a piece of paper, then you demanded some evidences, then another 10 pieces of paper. And then you make a bunch of paper, go to the director and then go to the office and then say, hey, can you approve it? Then he will approve it. Then he will give another letter for me. And then another n number of pieces of papers would be there. And if it is reduced somehow in online mode, then it means we contributed to then one. Right? Encourage traveling in groups. We have buses. You might have seen Aries bus. We don't use our cars independently, individually to do all possible works. Slowly catching up to have solar installation, changing windows. So we have an old institution, old building. So recently we have started changing our buildings' windows. There is also a contribution towards sustainability in the sense that let us say it's a cold place, I need to run my heater for 8 hours, but if I have a good window which has no air leakage, then definitely I will run it for 2 hours. And I will have enough heating in my room so that I can sit and do science. So that's another way to approach towards sustainability. Protecting the environment, ensuring that the greenhouse effect is minimized. So that's the small efforts done by each and every individual, and that's how if we kind of club them all efforts done by, let us say, 50 people sitting in this room, then the carbon emission would be minimized by a factor of 50 more. Let us say for some activity, if we all 50 contribute, and that's how from 1.3 billion people in India. Increasing awareness among people about Devasthal and areas about air, light pollution, and many activities. We have a separate branch to study that what kind of carbon contents are there in the atmosphere, what is their effect on atmospheric changes and weather and so on. So we have a separate study branch going on here as a part of atmospheric science activity. So these are the things which are kind of relevant to tell you. I would like to stop here saying a message that for sustainability, I took example in the last that how we are contributing apart from many other things. If you list, there will be n more, which you can then ultimately boil. You will see that it boils down to contributing towards sustainability, protecting environment, reducing carbon dioxide or carbon in general to a minimum possible level. Thank you very much.
Sir, thank you for nicely bringing out how astronomers can contribute to this issue of sustainable future and the challenges that we are facing as far as the climate crisis is concerned. You also nicely brought out some of the steps that we have taken at Aries to in some way contribute or to reduce our environmental impact. And he also gave the example of many of these observatories. So at present and probably in future, many of these observatories will also be operated in remote mode, okay, where you will not have to physically go there to take observations. And that's how astronomers have contributed. And after this session, when we'll be going out, so while coming, probably you may not have seen, but when we go to slightly higher height to see the telescopes, at that time you can see on top of this auditorium also we have a lot of solar panels. So these kind of efforts we also have taken at Aries. And so in the initial talks that you might have witnessed in the online mode, I had also given a brief introduction of what we do at Aries, atmospheric science and astronomy, and we have a lot of instruments, lot of telescopes. And similarly, sir mentioned that many big telescopes are there at different sort of places, dry deserts and things like that. So these are huge projects, and some of these even bigger next generation projects like the square kilometer array sir mentioned. So these kind of massive projects are not just done by astronomers or scientists. Of course, they are involved in the planning and usage of these facilities, but the actual building is done by a team of dedicated engineers. Okay, and because there are a lot of complex things involved, a lot of complex parts are involved. It's not just astronomers can know everything as far as mechanical engineering is concerned or electrical engineering is concerned, or the optics is concerned. So there is a huge dedicated team behind all these kind of projects that are there. So even in Aries we have a dedicated engineering team, and I invite Dr. Kumar to talk about the engineering aspects that are involved in the operation of these facilities. So Dr. Kumar heads our engineering division, and he has done his PhD from IIT Bombay. Yeah. I can move the slides for you.
इसके से हो गए
हाँ
हाँ ऊपर आ रहा So very good morning, all of you, all the enthusiastic people here. As we are celebrating this National Science Day, and the theme, Shashi has given a very good elaboration. It has very nicely described what is sustainability, why it is important, why this is the theme of this year. I'll be mainly talking about engineering aspects of telescope. But before this, let's take a moment to summarize what Shashi has said. It is very important, as he said, sustainability. So by now you might have understood what is it. So he said there is no planet B. We have only one planet Blue, which we have to maintain, and we have to continue for a long period of time. So what has to continue for a long period of time? It's social development, economical development. This works. Pointer.
I think you have to press and then. Sorry. Yeah. This,
Okay.
You have to press
fine,
this
fine.
one.
And environment. Okay. So first of all, social development. This is very important. What is social development? Humans are social animals. They are intelligent social animals. And it's very important to have a well-being of every individual. Remove poverty, provide security, provide healthcare, provide care, community service. All this removes worries in our head so that we can work
very efficiently. We can think very efficiently. We don't have worries in our mind. We can reach our full potential and we can start our journey peacefully towards working towards our dreams with confidence and dignity. After that, only we can think of economical development. Once we fulfill our dreams, we are ready to do the economical development. What is economical development? It is creation of wealth and resources for the nation, for the community, mainly for the benefits of the people living in the community. Okay, it is growth. It is modernization, industrialization, progress in agriculture and infrastructure. So this gives a quality of life, better employment, better education, better housing, better healthcare, and transportation. So in turn, it sustains social development. So society, once we have a very well established society, it also leads to economical development. And the economical development, it sustains again the society. But what about the environment? So as Shashi has said, that it's very important to conserve the nature, use natural resources, use renewable energy. So we have to preserve this environment. If there is no environment, we cannot sustain. Okay, so we have to utilize the resources which do not degrade the nature, which do not endanger the nature, and it preserves ecology and environment. So that's why this is very important. It's very important for youngsters like you. You are the future of tomorrow. So you have to think how to use science and technology for sustainable future. So as we said, this is an integrated approach. So all the institutes have to work together, all the science, technology, even the medical institutes, we all have to work together, share our resources, knowledge, and think how to lead forward in this way. So now we'll jump back to engineering. So engineering is very important for telescopes. The scientists here, they are from astronomy and atmospheric science background. They do research, they do experiments, they do observations. So the atmospheric science people, they study the Earth's atmosphere, the composition of the atmosphere, how it is changing, how the wind is changing, right? So they need instruments to probe this atmosphere. Similarly, the astronomers, they need telescopes to study the universe, to observe the universe, to validate the theory put forward by the theorists. Okay. So what are telescopes? What is the meaning of telescope? Anyone here? Just a dictionary meaning of a telescope. Tele means far, right?
To observe the far objects,
Yeah.
like the celestial bodies.
Right. Yeah, simple definition is tele means far, scope means seeing. It's an instrument which sees far away objects, telescope. So this girl is holding a lens. Okay, you might have used this lens during your childhood days. So what is this? It's a magnifier. Okay, you can magnify anything using this lens. So it's a simple telescope. If you see these black lines here, these are actually the characters. Using a magnifying lens, you can see that these are not just black lines, these are distinct characters. So the astronomers, when they see the sky, they want to see distinct objects in the sky. Stars, very tiny objects in the sky, which may appear a single object, but when you use a telescope, you see that it's a galaxy. Okay, it's a cluster of stars. So to see those fine features, to magnify those features, astronomers require telescopes. So what is telescope? If you combine many such lenses, you get a telescope. Binocular is a telescope. It has two telescopes. And this is a simple telescope. You can see a distant object with this. But astronomers want to see very, very far away. So they need a large telescope. So we'll come to that, why we require large telescopes. So as I said, telescope is combination of lens. It brings distant objects closer to your eye. So it appears as if the objects are very, very close to your eye. Okay. what it does, it collects a lot of light from the object. That's why it is very big. And it has to focus, form an image close to your eye. Now, just seeing the objects is not satisfactory. You need to capture those objects. You have mobile phones, right? You use cell phones and all. Your parents have cell phones. You take pictures, you capture the memories. So astronomers want to capture the objects seen by the telescopes. So these cameras, we call them photo detector, right? These are nothing but they detect the light, they detect the photon. So they are photo detectors. They convert light into the digital image, right? So instead of eye, we keep a camera here to capture those images. Now, as I said, the telescopes are very large. They are important for astronomy. Lenses are very, very heavy. So when you build a large lens, it becomes very heavy. So they found out a solution. Why not use mirrors instead of lens? Mirrors are very, very light. Okay, they have just one surface and the thickness is negligible compared to a lens. So they are very light. So combination of mirrors can also form a telescope, right? So this is light, and this also removes some of the problems because of these lenses. They separate colors. So when you see a white light, it separates colors like a rainbow. So mirror doesn't do that. So it's much better than a lens. Right? So if you look at the sky from a city, you can't see stars in the daytime, right? Because sun is bright and it masks all the faint objects. If you go to a city in the night, sun is not there, but artificial light is there. We have malls, we have street lights, we have cars. So from even from Haldwani or big cities like Delhi or Mumbai, the sky is always lit even in the night because of the glow, because of the artificial light. So this is like the effect of sun, right? It masks all the faint objects, so you can't see many stars from a brightly lit sky. What is the solution? Is switch off all the lights in the city, which is not possible, right? So you better move to a dark side. So when you move to a dark side, you can see more stars, right? But there's one more problem in the cities. There's a lot of smog. Smog is combination of smoke, dust, fog, water vapor, everything, right? So it reduces the transparency. It blurs everything, right? So even when you move to a dark side, you can't see very clearly. And this smoke rises up, but it settles within 1 or 2 kilometers, right? So you have to move to a mountain, which is much above that height, 1.5 kilometers. So Nainital is like 2 kilometers. There's another site called Devastal, which is a very good site where we have a largest telescope, 3.6 meter telescope. So that is at 2.5 kilometers. So there is no this aerosol, this smog there, right? It's a very clear site. So there, the sky appears like this. Just without a telescope, you can see this from Devastal. So you need to move to a dark mountain and if your eye can see this, a telescope can do much better. So it's better to place this expensive telescope in a very, very good site, right? So as Dr. Shashi said, we need large telescope. We need to gather a lot of light, right? So what is large telescope? When we say 3.6 meter Devastal optical telescope, mirror has a circular pattern, right? So the diameter of this mirror is the size of the telescope. The diameter of telescope, which we have in Devastal, is 3.6 meter. So early telescopes were small. Now slowly the size of telescope is increasing. And in future we'll have 30 meter telescope. Diameter is 30 meters. It's comparable to a size of football ground. But this is the size of the telescope. So one is you need a large size, and second thing is you need to see sharp objects, right? You use a magnifier, you can see distinct characters, right? So you use a large telescope, you see distinct stars. So these are two stars here. A small telescope can't see this. A medium telescope can resolve it into two objects. And if you have a large telescope, you see very, very sharp, distinct objects, right? So that's why so this resolution is directly governed by diameter. You have a large diameter, you get a better resolution. You have a large diameter, you collect more light. That's why people are moving towards larger and larger and larger telescopes, right? So once the telescope becomes larger, I can't hold it with my hand. And if you have seen your mobile cameras, when you zoom in and make a video, everything starts shaking, right? So advanced mobile phones have some stabilization, software stabilization, optical stabilization, many new technologies are used. So even if you move, shake, it unshakes your image, right? Makes it stable. So telescopes are heavy, very, very heavy. Even if I can hold it, I can't hold it steady, right? So we put this telescope on a robot. So this is a hand of a robot. It's called fork of a telescope or a mount of a telescope, which holds this huge tube. And this telescope is this Devastal optical telescope. It weighs about 120 tons, huge, right? So it's very important to hold this telescope, move it stable, keep it stable, and move it precisely. When you look at the sky, you have to use two motions, right? You have to look north and south, and you look east and west. So telescope also does that. It has two motions. It moves the tube from north to south, and it can rotate the tube by 90 degrees and move it east to west. So you cover the entire part of the sky. That's why you have two motions. So this robot or this mount of a telescope, it swings this tube up and down, and it can rotate the entire structure so that you can move east and west also. Now the objects are moving in sky. Sometimes you are interested in this object. Sometimes you want to see some objects here, some planets here, some stars here, some galaxies here. So you have to move your telescope everywhere. So this robot has to know where to move. So this has sensors. Sensors tell the current position of telescope. It tells you just like a GPS. No, it tells you where you are. So this telescope has sensors. It tells the position of the telescope, how much it has to rotate to move to this star. Second thing is it has very, very precision motor. Like electric vehicles are now very, very popular. It has precision motors, right? They are brushless DC motors. So this has brushless DC motors. Much before EVs came, telescopes are using this technology. So this has precision motors to move the telescope, and you need to tell this telescope where to move. So there's an app. We use an application, software application, which runs on a computer. You tell that computer tells the telescope where to move. And how precisely it can move, because Earth is rotating, you have to also track the objects continuously. And it has to be very precise, because you're seeing fine features, very, very fine features in microns, right? So it has to very precisely track without shaking. So if you tell this telescope to move by 1 degree, it can exactly move by 1 degree. If you tell it to move by 1/60th of a degree, it is called 1 arc minute, it can do that. If you tell it to move by 1/60/60, that is one arc second, 1/3600, it can do that. And it can do even better. It can easily move by 1/36,000th of a degree, precisely, this heavy structure. That is the precision of this telescope, right? It can locate the star in sky. It can track it with an accuracy which is finer than your hair strand, right? This huge structure. So that is the complex engineering behind this telescope. If it doesn't do that, you won't see point sources. You can't see stars. You'll see some trails. Or it is shaking. Your image is not circular, shaking, or it is defocused. So that's why it has to be very, very precise. And also the lens arrangement, the mirrors, all the components in the telescope, they have to hang. They're hanging in the telescope, right? They should not vibrate, should not move. They are huge. They may deform. So just like your advanced cell phones, it has some optical stabilization. We call it adaptive optics, or we call it active optics. So it's again a kind of a robot which keeps counter shaking the mirror, or which it counter aligns the mirror for any deformations. So this is a beautiful image of Saturn. You can see how the blurring or defects or the shaking of the mirror, shaking of the telescope does it. And original image, the very, although you are seeing the fine features which you can't see using normal telescopes, still it is not as original as it was, right? That's why you need precise positioning, motion control of the telescope. We call it motion control. When you move the telescope, you control it. Precise motion control, precise mirror control of the telescope to align the optics. So we need all this technology, and which continuously aligns the telescope and removes all these aberrations, all these defects, and gives you the original image. Next, please. So this is the technology, optical image stabilization in your phones. It was actually used in telescope in 1980s. It came to cell phones, I think after 30, 40 years, but it was actually used in telescopes. In ESO telescope, what Dr. Shashi said, ESO is a big astronomy community of Europe. And this is our telescope. Our telescope also has this image stabilization, and the optics engineers, they precisely keep this mirror on this motors, linear motors, which can move the mirror very precisely. So lot of engineering is required for telescope. Many of the bright minds here would like to become engineers, some would like to become doctors, some would like to become scientists. Many professions are now successful. So a lot of engineering goes into telescope, but a lot of integrated engineering goes into telescope. I can't just use electronics. I need to understand the mechanism to apply the electronics. So I need to understand mechatronics, combination of electronics and mechanical. I need to understand optoelectronics, combination of optics, mirrors, and electronics. Right. Optomechanical, combination of mechanical. So optics is very important. So we require optics engineers group to understand this telescope, to maintain this telescope, design, upgrade. And this telescope worked for 40 years. So they have to maintain this performance for 40 years, add new technology to it. Then we need mechanical engineers to support, make these huge structures, 120 ton, precisely. Then we need electronics engineers to precisely apply the motion control, the sensors, motors, control them. So we need to develop these controllers, these are very advanced controllers which can talk to the computer and precisely control the telescope. Then we require software engineer, the applications. You can click the star and it can move there. You can give any position and the telescope can precisely move there. So we require very complex software development for this telescope. So this is the combination of electronics, mechanical, optics, and software engineer, which is led by experienced scientists. We get a very good telescope. So more or less, this is the overview of the engineering aspects of telescope, which I wanted to give an overview about.
Thank you, Kumarji, for introducing the students with the technology. Just a brief overview, or just a flavor of the kind of technology and engineering aspects that are involved in the operation of modern telescopes. Okay, so with this, we come to the end of the first two talks, and or rather the session over here. Before we break up, maybe we can have a short question answer session. If you have any questions related to the two talks presented over here for Shashiji or for Kumarji.
That is more important. डरने की जरूरत नहीं है, कुछ भी पूछो जो तुम्हारे मन में आता है, don't be hesitant. हो सकता हो हम ना आंसर कर पाए. That's a good question, but just try.
Feel free.
Don't be shy.
So all are in which class?
Class 12. How many?
From class 12.
Which is a
And the rest of the high school?
anyone below high school?
No, class 9 is the lowest, I think,
Okay.
today, right? Class 9? Yeah. So class 9 to class 12. That's the.
Sir, just one question. I'm talking to you from as a layman, okay, having nil knowledge of astronomy or satellites. Suppose India and the world has launched so many satellites over the years, okay, about say millions maybe, for different uses. We know, I mean, from what I know is a satellite has a particular time frame. It works for 10 years, 15 years, 20 years. And then after that, the concerned country says, it's over. I cannot use it anymore. The life of the satellite is finished. And then it remains into space. But my question would be this, like if this continues continuously with the countries launching satellites, a time will come when our space will be full of these objects. So how do we stop the garbage in outer space?
Yeah, thank you, sir. And it's a very nice question. I wanted to touch upon, but due to time limitation, I did not touch it. That problem, it's a well-known problem, and with time becoming serious enough for the concerns which you raised, called space junk.
Yes.
And space junk is, as you rightly pointed out, that thousands of satellites are just hanging around in the orbit. And from our basic physics, we know that some of them, you in your previous years, you might have heard about an accident called Skylab. Skylab gira hai, 70s. Ultimately, wo gira. That is one fate. That now, so after 70s, many more and many heavy satellites are already there. And once we launch satellites, satellites have low Earth orbit and high Earth orbit and some, geostationary satellites. 36,000 kilometers onwards with the basic physics. And from our physics, we also know that what happened with the Skylab, that to gravity, after some time, gravity will dominate and then the orbit will be decaying. And with time, a point will come that it will be, low enough to be not to be affected by, the orbital parameters, but rather will be dominated by gravity. And at some point of time, it may fall somewhere, in some, some urban area or something, may create damage and things. But there are many, it may happen 1 in 1,000, maybe in a year or two or something like that. But the rest of them, as I said, lower Earth orbit or higher, they are simply hanging around. And they're very potential damage for not only future missions, but also for the satellites there in the orbit. So once in a while, they are creating damage to existing ones or things like that. So far, all big agencies like ESA and NASA and ISRO, of course, are thinking about, these space junks to somehow map them and to ensure their orbits and, like we map asteroids and all other, small near Earth objects. So these potentially hazardous, man-made objects are also there. And we are still in the process of mapping, although we know some of them, spy satellites and so on, we don't know even, only individual countries know. So there is no clear-cut evolved there is a strategy that we can do this, we can do that, and so on. But the point is that even if you are trying to destroy one of them in space due to some technology or something like that, they will create, additional debris, and they will act like another 1,000 satellites or something like that. Because if the existing one is there and if someone hits there, then it may create a potential damage and so on. The idea is there to somehow, make sure that some of them which are still controlled we have, then some of them could be, lower and lower and make sure that they are dropped and so on. But the number is too much, as you said. And just by adopting techniques, we cannot really get a permanent solution of it. And because of our needs and development, so we cannot stop also flying satellite. We have to do that. But the space junks, that how to really make sure that all those junks are cleared up is a big issue. And they are trying to map it, and they are trying to monitor it continuously, that where they are going, how they are evolving. Maybe in another few years or so, we might have a practical strategy to clear them up. At the moment, it seems that we don't have any kind of very established way to clear them up. So that's a big issue.
May I just contribute to that? So as Sir gave the example of this Skylab, which used to be there in the 70s. So earlier, a lot of this uncontrolled satellites were there, and many of them are there even now. But at least for the past some time, a lot of the missions have been designed, particularly the low Earth orbit ones. They have been designed in such a way that before they become completely uncontrollable, they do something which is called as a controlled fall or controlled decay of the orbit.
Some sort of maneuver.
Yeah. So the way the orbits are maneuvered in such a way that the satellite may ultimately decay in the orbit. I mean, the orbit decays, and ultimately it should fall in the atmosphere. And if it is a small satellite, it will completely burn up in the atmosphere. If it is a large piece, then the decay is designed in such a way that at least high chances that it falls in some sea or ocean. But of course, the many satellites which become inoperable or uncontrolled for some various reasons in space, yeah, they still pose a challenge. Or if there is some collision between, say, multiple satellites, or some of these defense tests that various countries have done, like destroying a satellite, as Sir mentioned. So even that also has created more debris. So if it is a low Earth orbit, then because of the atmospheric drag, a lot of these burn up, but many of them are still remaining. So just now, many countries, like for example, NASA and Japanese agency, so they are now planning for various missions. These are in developmental stages, which can sort of, act as a fishing net in the space to filter out these smaller particles.
Again, the sustainability. Let us say if I'm flying something and which is working for 5 years, then recently what has happened is that they have a plans that how to deorbit it and make sure that it, like we mentioned about maneuvering in such a way that it safely comes into gravity and somehow falls to a safer place and so on. But still thousands and thousands are there up, and I mean, still work is going on that how to trap them.
Any other question? Yeah.
A question related to what Sir asked. So, like in the recent times, you've seen one of the space stations, I think they call it, of Russia might fall on China or in India. Like it's causing a great threat to India and China because of the sanctions of United States of America. How do we like see this, and how do we control it? And how do we differentiate a space station and the threat that it might cause when it falls on Earth, like not an ocean, in comparison to when a satellite might fall if it is not controlled?
See, at the moment, as far as the space station is concerned, the only space station working, and they have made it a joint mission, and that is International Space Station. And International Space Station, it's a joint venture of ESA and NASA, and JAXA and So to ensure for the connected question, as you said, they have ensured at the moment that only one space station should be there, which is ISS. And most of the experiments, people are in collaborative mode, putting their instruments or going there, sitting for some weeks or days and coming back and so on. So recently, China has started activities having its own space station, which has not fully evolved. But yes, the work is going on. As far as the existing one ISS is concerned, that there are some challenges and some cracks have appeared. And I also read about it that there is a plan to make sure that, like Dr. Virendra mentioned, that at some point of time, maybe few years down the line, they will ensure that because it's pretty low Earth orbit and it has been designed in such a way that its maneuvering is having it has more flexibility than a typical normal satellite, which is not low Earth orbit. And since it is low Earth orbit and a lot of maneuvering is already designed and it is controllable. So we are pretty sure that whenever it will be required, because it's as big as it's like a few times, maybe 10 times of this room size and so on, the overall lab, and its solar panels extended over much larger units. So it will be possible to maneuver it to make sure that whenever we want, few years down the line, it will be lower and lower and lower, and ultimately it will enter into the atmosphere. Some part will be burned and some will be safely dragged towards some area where human beings are not there, or in ocean or something like that, and maybe from there it will be collected. And again, the sustainability.
Sir, but given how massive the ISS is, wouldn't it be a huge tsunami threat if it even crashed in the ocean?
No. It's simple. It is not that massive. Maybe if it is a few tens of tons, then if it is falling with some X velocity, that is not going to create a big tsunami kind of thing. I mean, some level of tsunami may happen because if some projectile falls with a huge velocity, let us say 1 ton, so one can calculate that how big the waves will be there and so on. So tsunami, I mean, so far if some big some sort of asteroid or big, massive, much more massive than that of ISS itself. I don't remember how many tons exactly ISS is, but if you see it and if you try to calculate that, if it is falling with X velocity, what will be that tsunami potential and how intensified it will be. But keeping the small mass of it and the kind of velocity it will be maneuvered, it's highly unlikely that some potentially damaging tsunami may appear out of it.
So as we all talk about reducing the carbon footprints, so in the near future, will it be possible for the scientists to develop some spacecrafts which at least not just reduces or minimizes the carbon footprint? So is it possible for the scientists to, in the near future, to develop such kinds of spacecrafts?
No, how is spacecraft will
We all say that we can take the energy from the sun or the resources which are already present. So is it possible to develop a spacecraft?
Yeah, there was some experiment because in the night you can't see the sun, right? So just like moon, they wanted to use some reflectors, large reflectors in space to direct the energy in the night also. But it's in a very experimental stage because the kind of energy you require for the human activities is very, very large. So they're exploring such possibilities, like you said, having some kind of space.
So it's possible
Yeah.
to develop.
Yeah, but it will be in maybe once you guys become so you have to think about this.
See, just to add to that, I mean, a lot of things which may seem impossible now, in future it may be an ordinary thing. Couple of 100 years ago, flying through atmosphere, like a bird, crossing continents in the matter of hours, it was like a magic. But now it's an everyday thing. So a lot of these technologies, some of it may materialize, some of it may not. Like for example, if you see, very old comic books, like or graphic books, say 100 years ago. So they have these cartoons where they have shown a classroom of students, not sitting in the classroom but somewhere else, and they all are wearing something like a headphone, and they say that whatever the teacher is teaching, they are not listening. It is directly getting transferred to their brain, something like that. So I mean, a lot of things may become true in future. A lot of it may be just a sort of wild ideas, if you want to say.
So we have a secret undisclosed, competition that whosoever will ask questions will be awarded, and only St. Joseph's has asked. So others are already out of this race. So make sure that you are in this.
What reward are we
एक से नहीं, अभी और ने नहीं पूछा, तो it's just 1 versus 0. कोई और पूछे तो. Let's take some question from non-St. Joseph's. Anyone?
Like the satellites that are nowadays very useful. So like sir, war which are happening nowadays, like Ukraine and Russia, they are not that much happening or use of satellite. But in countries like India, so in higher altitude like Jammu Kashmir, army usually use that satellite communication. So sir, it is possible that satellites can be hacked or cyber war can be done through this. The
Yes,
system,
already there. I mean,
the system can be hacked or it can be saved. That much be protected. Anything can.
Well, if you're asking about like satellites are heavily used, some called military satellites. So why Ukraine and Russia are going to tell us that they are using or they're not using? They are of course using. If you use, if nobody else is using, then at least US is using. Right? You see in media, you will see a lot of images which are actually satellite images. And India has also satellite military satellites and equipments, and something called remote sensing and other kind of satellites, and they are being used for both military and non-military purposes.
The like army persons, so they communicate between each other, the head office and like.
They do. That is not the domain because it's online Zoom event. Yeah, they are of course. Whosoever is capable, they are of course using military satellites, including India.
So the information can be taken by them.
By them?
Like hackers and all that.
Well, hackers can work through a network which they know about. If we have a dedicated network for which very limited information in public domain, then hackers stuffs will not work. And all these military and there are certain channels, they use a very different kind of decoded technology and networks, which is not known to us. So if you and me wants to work as hackers, then we can't do that. And everybody has their own dedicated devices and so on. That's the question.
So is there any upcoming project in future which is bigger or more precise than the 3.6 meter dot?
Yeah, so one is a 30-meter telescope. So both Dr. Shashi and I both are involved in that. So this is very ambitious projects. One is the JWST, which was launched recently, right? James Webb Space Telescope. So that was the recent thing. Now after that, there's hopes are there so the 30-meter telescope will become the largest ground-based telescope. India's partner to that. There are 5 countries working together to build this telescope. Within country also there are plans. There's a plan to build a large optical telescope, close to 10-meter diameter. Yeah, but these are all very big telescope. It takes a lot of time. Sometimes it takes a decade or more to build these telescopes.
Last 1 or 2 questions, maybe.
लड़कियों ने नहीं पूछा, एक ने पूछा बस. Rest, lot of girls in the front row. आप लोग कहाँ से हैं, किस स्कूल? एक क्वेश्चन तो जीआईसी से बनता है. जीआईसी वाले तो बहुत तेज होते हैं और पिछले बार जीआईसी ने बहुत अच्छा परफॉर्म किया था.
हिंदी में भी पूछ सकते हैं.
नवोदय वाले.
Yes,
तुम हिंदी में पूछो, कुमाऊनी में पूछो, जैसे ही पूछो हम लोग तुम्हें रिप्लाई करेंगे.
Yes.
लेकिन पूछो.
So like you mentioned that each satellite has a time limit. So after it decays from its orbit, like if it's a small satellite, you said that it burns within the atmosphere. But if it's a big material, so it will just deplete in the ocean. So wouldn't it cause harm to the nature?
Yeah, sustainability is challenged that way.
Yes, sustainability is not.
Yes, you're right, but we can't help. The whole point is that somehow space jump should be cleared, even if it is harming something. Like to go to US, you can't go by road, right? You have to go by flight only. No matter whether you are emitting carbon or contributing to carbon overall budget. So it's a problem, something like that, where we don't have control at all. It's okay. Somehow the idea is to safely, make sure that it is grounded and no harm has been done. Yeah, potentially if it is creating some burning material and something, which we don't have control over it, then we can't help. So that much we have to bear, I would say.
So what should be the precautions taken so that it does not harm?
What should be precaution for what?
So that it does not cause harm to at an extent.
Well, I mean, that's a challenging job for you, being a youngster. You work in this direction only, and you make sure that you get a solution for it. Because we are getting older and we are 50. So you take another 10 years and get an answer for it. No, I don't know. Whatever scientific community so far and the technologists, we don't have a solution. What I'm saying is that it is expected from you all to, have solutions for problems like this. So that's an open question.
I would like to add here, before there is a solution, there is a space consortium. There are rules. If you launch a satellite, what rules have to follow. And when this, I think there's also a group which says when these satellites are disintegrated or they are blasted once their life cycle is over, they become small particles. And when these small particles they are orbiting, they are spiraling towards Earth. They attain a lot of velocity, and the friction once they are into the atmosphere, they're small enough that they burn up the atmosphere itself before it hits the Earth. So that is one solution to that. But yeah, like Dr. Shashi said, in future we'll have more clarity on this. Maybe you guys can lead these things in future.
Like, so it is burning, so in that case also it is emitting carbon.
Not only carbon, many more elements. Because
But the main is carbon. So what can the steps taken?
So the components used in spacecraft, it should not pollute once it burns in the Earth's atmosphere. But it's a technology, it's required for technology advancement, right? So you have to reduce the carbon footprint in other areas so that you can leave some margin for the satellites, which are important. This how a balance can be made.
Thank you, sir.
You have asked one, so maybe the girl.
So, we all live in an era of space race today, and there are multiple countries which are launching different projects each and every passing day. They're thinking about different projects. Wouldn't it be more sustainable for the environment if all the countries form a cohesive manner, like all collaborate together rather than forming this race between different countries?
Yeah, as I said, the International Space Station doesn't belong to one country anymore. And then I was talking about ESO, European Southern Observatory. So all European countries have made their own single ISRO kind of structure called
So can
ESO.
India be further
ESO. Well, yeah, in certain projects, you're right. For example, if India is launching one rocket, then there are several payloads. You might have heard a couple of years back that 104 satellites were launched by one of the Indian rockets, right?
Yes.
So that was an example where many countries came together and they said that, hey, I have a satellite to be launched. I don't have a rocket for this to put and keep it in space. And India has a big rocket which they are going to launch. So here is the scientific project I have, and I will pay certain amount of contribution to the charges of all, and please launch my satellite. So that's how some 17 or maybe I don't know how many countries, but the overall launch number of satellites which were put in orbit was 104. So those kind of collaborative efforts are always there. But everybody joins and nobody else does anything independently. That is not going to be that practical for many reasons.
One last question.
ये लड़का पूछ रहा था कुछ.
Yes.
So, according to many various surveys, less than
surveys?
Various surveys, only less than 1% of the observable universe is available to our eyes. So, what are we planning to go further into the outer systems of the atmosphere or the solar system to see more? Is there any sort of plan, or are we just planning to keep our telescopes on Earth rather than sending them out to space?
No, for your information, if I understood your question correctly, we are for observational point of view, we are just not limited to our solar system. We know now our galaxy, we know many galaxies far away, and if you believe that Big Bang was true, and when the explosion happened from there, it was a 13.6 gigayear the overall life, and then we now know objects which are sitting, as early in time as when the universe was, instead of 13.6 gigayear, it was only 10 or something like that, maybe 3 or 4, or maybe even less. So we know galaxies to very far away universe. That's the early universe. And now JWST is also launched to probe that very early part of universe. Because we all know that it was a Big Bang and all energy dominated universe was there. And at some point matter dominated universe came into existence, and some, initially hydrogen came, and then helium, and then cluster of galaxies, and then proto-galaxies, and then galaxies, and in galaxies the stars came into existence. In our Milky Way there are 10 to 11 stars, and sun is one of them. And sun has its own solar system, so possibly all 10 to 11 stars have their own solar systems. So if there are 10 planets we have, and multiplied by 10 to 11 stars, and then another 10 to 11 galaxies. So we are talking about a system having 10 to 11 multiplied by 10 to 11 multiplied by 10 to 1. So 10 to 23 or something like that is a system where electromagnetic radiation could be seen, or possibly for a large extent we have seen. So research and projects are going on to probe more deeper and understand that wherever electromagnetic radiation is not coming from, that is only 4% of universe. We believe that universe is seen in electromagnetic universe, but there is part 96% which is defined as dark matter and dark energy. We don't know anything about it. So as long as, unless we understand that the full evolution and the full structure of the universe will not be possible to be explored. So projects are going on to understand those aspects beyond our galaxy, I would say, or even within our galaxy. We are not very sure. Apart from electromagnetic radiation, recently you might have heard gravitational waves. Those are not part of electromagnetic radiation. Neutrinos. So these kind of aspects, that's astronomy, treat them and define them something called multi-messenger astronomy. where you are not only dependent on multi-wavelength observations from the electromagnetic part, but you are also probing non-electromagnetic part. And that's how people are trying to understand whether from by understanding and taking an integrated effort. Again, science and technology with integrated effort, as Dr. Kumar mentioned. All technologies are coming together. All sorts of engineering branches are coming together to ensure that if it is possible to answer some of these questions with greater and broader knowledge.
Okay, so we come to the end of this session. I thank both the speakers for joining us and giving an overview of how the sustainable approach can be taken as far as science and technology is concerned, and how Aries is also contributing to that. So now we'll take a break. The competition again will start. Online, actually, very few. Okay, online. There are very few people today because of the exams.
Yeah, sure.
So I think
we are running.
Yeah, we are also running out of time.
Yeah.
So outside, we have arranged for some snacks. You can proceed for the snacks, and then we have also set up a solar telescope to see sunspots. And depending upon the time, like how it works out, we'll either have the 40-inch tour before lunch or probably after lunch. But the competition will be the extempore speech competition will be from 2. Okay. जावेद YouTube पे एंड कर दीजिए और Zoom रूम भी अभी बंद कर दीजिए.